Hello everyone, my name is Kamar Azabi and I'm here to present a sponge inference serving with dynamic SLOs using in-place vertical scaling. To give you some context, I want to mention that more than 90% of data center compute for ML workload is used by inference services, such as car detection that we are going to use heavily in this work and intelligent personalities such as Amazon Alexa. So there are some requirements for inference serving systems, inference serving in general. They should be first highly responsive to provide some sort of latency guarantee, and they should be cost efficient. So ideally the least resource consumption, the least resources that should be allocated to a deep learning model. To have some answer to that, we have a temp resource scaling, which are mainly composed of two scaling mechanisms. The first one is vertical scaling, or especially in-place vertical scaling that can adjust the resource, the computing and memory requirement of a deep learning model in place without without having the downtime. Or on the other hand, we have horizontal scaling, which is more cost efficient, but it suffers from the cold startup issue. So to add to top of that, we have the users move, and with that, there will be some fluctuations in the network. And then it means that we have some reduced time budget for processing requests in the server side. As if you can see on the figure here, we have a fixed SLO, and then some of that will be allocated to network latency, and the other will be allocated to the processing latency. To have kind of more context here or some data, as you can see, as the user moves, the throughput changes. And if we have different data, if you are sending some data over the network, such as 100 kilobyte or 500, it reduces the remaining SLO dramatically. So to kind of answer to that kind of user dynamism, we are going to use in-place vertical scaling, which is more responsive in the framework named Sponge. The first question is that how much resources should we allocate to a deep learning model? We know that there are some linear relation between latency and byte size and some inverse relationship between latency and CPU allocation, as you can see here in this example. There are more examples in the paper that you can look for. So the system design that we have to kind of answer to the user dynamism is in-place vertical scaling, which provides a fast response time. We have a request reordering because some requests will have a shorter deadline, and then to increase the system utilization, we have dynamic batching. To evaluate a sponge, we used a set of the horizontal scaling named FA2, and then we kind of used two statically allocated CPU cores, 8 and 16. Compared to them, Sponge can save up to 20% resources while guaranteeing 99% of the request latencies. For the future direction, we discuss in this work we discuss just vertical scaling. However, there are another mechanism named horizontal scaling. Therefore, we ask this question: how can both scaling mechanisms be used jointly under the dynamic workload to be responsive and cost efficient while guaranteeing SLOs? Thanks for listening.